Welcome to a video lecture, the first one for chapter 25. In this one we will begin to look at mirrors and the reflection of light. This follows along in chapter 25.1 all the way up to 25.3. Let us begin. And we can be alright if we're a little bit vain and spend a little bit too much time in front of the mirror because we're going to be looking at mirrors a lot. A point source will produce light, and if it produces light, we'll get that light radiating out in all directions. These rays of light will form what we call wave fronts. And as the wave fronts or rays move away from the source, they decrease in intensity as 1 over r squared, which we've already seen this with a couple different laws. The universal law of gravitation, the Coulomb's law, the electric force thing. It decreases as 1 over the square root of the radius away. Now, far away from these point sources, these rays actually, we can assume that they're kind of parallel to each other, but this is a great distances away. Other than that, we just have a wave front. So you could have a plane wave front or a curved wave front. But we will, this is just kind of how waves travel. Almost all objects will reflect some amount of light on them. And what we actually see, and when we see colors, is we see the reflected light. So out there, a light produces white light, which consists of all the colors. And what we see is what's absorbed is all the other colors, and we only see the colors that are reflected back to us. Now, incidence refers to the incident ray, the ray coming into a surface. And the angle of reflection is the angle reflected back off of this. This is with respect to the normal. So within some, as long as it's a flat surface, it doesn't even have to be a flat surface. We can talk about along a surface, the incident ray always makes the same angle with respect to the normal of the surface, that's the perpendicular of the surface, as the reflected ray. For a smooth surface, we get what's called specular reflection, which is when if the rays enter parallel, then they're going to leave parallel, and they'll leave in that same order. Now, for an irregular surface where you get, and this is most surfaces in general, you have some idea of there's a diffuse reflection, which means that the light is just being reflected off in all sorts of different directions, but it's still moving off at the same angle with respect to the normal of that point. So the normal at the point where the light is being reflected off can be different. It may not necessarily be straight up. It could be off at an angle. It could be somewhere else. But you'll get some reflection off at an angle that is equal to the incident angle with respect to the normal. So the normal can change on an irregular surface. All right, when you look at a large plane mirror or any plane mirror for this fact, there are a couple of characteristics that happens. One, the image is upright. And this right away is going to tell us that it's a virtual image, which we'll talk a little bit about in a little bit while. But a virtual image means that the image is produced by the reflected light. Second, the image is always your size. And if you don't believe this, go find a large mirror somewhere in your house or something like that, where you can stand it up and put it flat against the wall and look at yourself in the mirror. And then, even have somebody help you stand it flat, but it's going to be flat against the wall. And then, because otherwise you're going to be looking off at it at some weird angle. And then stand back and walk back and forth and see if you can see more or less yourself. Not how much of other objects block out your body. Like if you do it in your bathroom, you'll have the countertop will block out your body. But you should always be able to see the same size of yourself. I really want you to think about why that is. It's kind of like the main idea. The other idea here with a plane mirror is that the image there's no magnification. The image is located at the same position within the reflection, or image. Yeah, it is an image. Is located the same distance apparently back from the mirror as you are. one of the things we'll talk about is whether the images are virtual or real image. Now, a real image is always 180 degrees reversed, so that means it's flipped upside down with respect to an object. That's really like the first hint that it's a virtual image is that it has the same orientation as the object. The second thing is that the virtual image is produced by light reflected off of a mirror, and that's like the physics part of it. It's produced by the light reflected off of the mirror. So as we move forward here with lenses and curved mirrors in the next video, we'll see more and more examples of virtual and real images. A couple of questions from the video tonight that I'd like you to fill out online. You know the drill. Boom, boom, boom. Questions, answers, go online. All right, anyways. How do the incident and reflected ray compare on a flat mirror? And assume that it is a smooth surface. Second, will moving closer to a plane mirror allow you to see an enhanced view of yourself? And by that, will you magnify yourself? And I want you really to explain your answer for this. Go try it. See what happens. I want you to see if you can come up with some reasoning behind this. And then, what are the differences between real and virtual images? Thank you very much. Have a good night, and I will see you in class tomorrow.